Alright, ladies and gentlemen, so what we're doing in this series of lessons is essentially we're repeating the last series of lessons. So you're going to get some more reps at determining trig ratios without a calculator, but we're not just repeating it to repeat it. We're repeating it in a new system of measure. Okay, so you're used to, in your life and in your previous math career, talking about angles in degrees. We are now graduating to a different unit of measure. We're going to start talking about angles in radians. So it's the same thing as like in your everyday life you might use feet, but in say physics or in different science classes we are going to use metric units. So you might say meters in those contexts, because this unit is more often used in serious big boy science classes. So we switch and we start to get more comfortable with this unit. We're going to do the same thing here with degrees and radians. The math in this lesson is not that hard. I do want to kind of introduce where this unit radians comes from, and then we'll talk about how to convert between the two. Okay, so let me draw a picture here. Okay, so I've just drawn two circles. We use these units to measure circles as well as angles, right? And my left-hand circle, we're going to talk about degrees, and then we're going to introduce radians using this right-hand circle. Okay. So degrees, you guys probably know that all the way around the circle is 360 degrees. So essentially, degrees, somebody a very, very long time ago decided, okay, let's, for whatever reason, divide up the circle into 360 equal parts, and that's how we're going to measure angles and parts of the circle and so on, right? So, a quarter of the circle is 90 degrees, right? So this would be 90 little tick marks. I'm obviously not going to draw them all. And then half of the circle is 180 degrees, and then all the way around is 360 degrees. This is kind of an unwieldy number. It's similar to like, okay, there's 12 inches in a foot, right? Somebody just decided that. And it became this kind of traditional unit measure, right? And then meters is a little bit more logical if you run into that in chemistry or physics. Like these units make a little bit more sense. Radians is the same way. So radian, notice it sounds like radius, which you guys have learned at some point in your math careers, I hope, that a radius is the distance from the center to the outside of the circle, right? A radian is the unit of measure for measuring the outside of the circle that is equal in length to the radius of the circle. Okay, so 1 radian depends on the size of the circle. So we're measuring the circle in terms of itself. Instead of deciding to just cut it up into 360 pieces kind of randomly, we're going to measure it in terms of a measure that it already has. So if I took that radius, and I sort of laid it out around the circle, so you can imagine it's made out of string, and I'm kind of bending the string around the circle or something like that. That length, this is 1 radian. And what we'd find is we could actually lay this radius, I think mine is a little big the way I drew it, we could lay this radius out 6 times all the way around the circle, 6 times and a little bit. The exact amount of radians that fit in a circle, you guys have seen this formula before. Circumference is 2 pi r, right? So the circumference, the distance around the circle, is equal to 2 times pi times the radius. That means all the way around the circle is 2 pi radians. Okay. So the reason we're going to take a little bit of practice in this is because measuring the circle in terms of pi is new and is going to feel a little bit awkward at first, but you're going to get good at it. And then you're going to be talking about circles and angles and stuff like that using the units that serious mathematicians use, which is our goal because we're serious mathematicians, right? So the fact here is 360 and 2 pi. So 360 degrees equals 2 pi radians. This is the fact that you really want to write down because this is how we're going to convert. sort of similar versions of this fact, right, is half of that 180 degrees is pi radians. You can use that to convert, but this is our conversion factor, just like 12 inches in a foot. Okay, let's look at some problems. These are not very hard. Let's actually start with our 90 degrees here. So we have a 90-degree angle. That's a good one to know in radians, right? So there's a couple different ways you can tackle these. What I like to do, because you can never mess this up, is I like to set up a proportion. So 90 over 360 equal to x over 2 pi, right? So 2 pi and 360 are the equivalent pieces here, and 90 and x are the equivalent pieces. And then you cross multiply and you solve, so you get 180 pi. You're always going to leave pi in here, is 360x, and then you divide by 360, you get 180 pi over 360. Sorry, I didn't give myself enough room here. Hold on. So 180 pi over 360 equals x. Rewrite that so it looks a little nicer. It does not look any nicer, but it's more legible at least. And then this reduces to like just pi over 2, or 1/2 pi. So that means 90 degrees is equivalent to pi over 2. Pi over 2 is a 90-degree angle in radians. Here's a delta math example. And actually I pulled up their solution so you know how to interpret this. They're using a somewhat different method. You can pick whichever you like better. Again, the reason I like this proportion method is because you can't mess it up. You line up your parts, you line up your holes, and you're going to get it right every single time. This is a conversion factor method, which you probably studied in your science classes. So notice pi radians equals 180 degrees. So they're using that and they're multiplying. So what we have here is degrees, radians, and then over 1, right? And then they multiply, and what you're looking for is your units cancel out. You're multiplying straight across, so you get 180 on the bottom, and then they reduce it. The way that this would look for something you're more familiar with is you'd do like 2 feet, and then you'd say 12 inches, 1 foot. You multiply straight across, you get 24 feet. Feet cancel out, and inches is what's left over. Okay, so you've seen this before as well. Again, you can pick which method that you would like. Whatever seems easier to you is what you should do here. And we'll leave it at that. So again, this is a scale you already have. We're converting units here. Pay attention to the angles you get. So like where we're going is we want to know specifically like 30, 60, 90, what those look like in radians, because we know that those are our important angles, and 45 as well. So pay attention to those as you work through it, but I think the actual conversion you're going to have a pretty easy time with.